Everyone, now let's talk about double angles. Now, you can figure these formulas out using the sum and difference formulas that we've been using pretty easily, but we're kind of moving past the trig proof phase. So right now, I'm just going to say, here's the formulas that you need. If it's the sine of 2 theta, then it's 2 times the sine of theta times the cosine of theta. And you'll notice for cosine of 2 theta, look, there's 3 of them. And the reason that there's 3 of them is because they do some substitutions. Remember, the sine squared theta plus the cosine squared theta equals 1. And if you, instead of saying cosine squared, you put in a 1 minus sine squared, then you'll have 1 minus sine squared, which is 1 minus 2 sine squared. You can do the same thing by substituting in for the sine squared. So depending on what you're doing or what information you're given, there's going to be a work smarter strategy for these cosine problems. It's not that you can't use any of them. It's just you usually want to work smarter, not harder. So I'm going to show you when we get to those that pick the right one and you can make those easy. So we're going to do pretty much the same thing we've been doing, where it says the sine of theta is 15 over 17. So I'll draw a helper triangle. And I will call this angle theta. That's supposed to be 90. This is 15 over 17. And this is a Pythagorean triple. I remember this is 8, 15, 17. You can do the Pythagorean theorem if you're not sure. Okay? Now I'm going to use the formula. And that's the biggest thing, is you have to realize that the sine of 2 theta is 2 times the sine of theta times the cosine of theta. And we're just going to fill it in now. So 2 times, what is the sine of theta? 15 over 17. They gave it to me. But the cosine of theta I didn't have originally, so I needed to find that 8. That's 8 over 17. Now when you multiply, you just multiply across. So we're just going to do 2 times 15, which is 30. 30 times 8. 3 times 8 is 24, so this is 240. And then 17 squared is 289. That's a perfect square that I just have memorized. 17 times 17. If it helps you, you can think of it as 2 over 1. You're multiplying the tops. You're multiplying the bottoms, you get 240 over 289. That fraction doesn't reduce. We're done. These are way easier. Great. Next. So sine of 2 theta again. Well, here they give me cosine. All right, it's pretty much the same idea. Cosine is 60 over 61. They're using a lot of these same Pythagorean triples. We've done this one a couple times. This missing side is 11. So do the Pythagorean theorem if you want. But it's 11, okay? We've seen a lot of these. Now, I'm going to use the same formula because it says the sine of 2 theta, so 2 sine theta times cosine theta. So 2 times the sine of theta is 11 over 61, and the cosine of theta is 60 over 61. So I'll multiply 2 times 60 times 11, and I'll probably use a calculator for this one. So 2 times 60 times 11, 2 times... Why is that not working? 2 times 60 times 11, 1320, and 61 times 61 is 3721. So this is 1320 over 3721. 1320 over 3721. Okay, again, weird answers. That's okay. They can be weird. Just hang in there. Use your calculator. You got big numbers. If that fraction reduces, you should try it. So you can always have the calculator help you. 1320 divided by 3721. Be like, hey, will you make that a fraction for me? It's like, yeah, it's the same. Like, okay, it doesn't reduce. Now, let's do a couple cosine problems. And this is where, like I said before, you want to work smarter, not harder. It says find the cosine of 2 theta, and they're giving you the sine of theta. So I can do it with just this formula. I don't need to know anything else. 1 minus 2 sine squared. So I'm going to think of this as 1 minus 2 times the sine squared of theta. If I pick the right one, this one only has sine in it. Well, I only have sine. 1 minus 2, 7 over 25 squared. Okay, now we're practicing fractions here, folks. So don't just reach for your calculator when you don't need to. 7 times 7 is 49. 25 times 25 is 625. So I'm going to try and do this whole thing here. 1 minus 98 over 625. That's 625 over 625 minus 98 over 625. So if I subtracted 100, it'd be 525. I didn't subtract that many. It's 527 over 625. Okay? Now, if you want, you can work that same problem out and you could use the other formulas, but those both have cosine in them. So you would need to find the missing side and then work the problem out. But if I work smarter, not harder here, I only used an equation that had sine in it because I was given sine. I was able to do it without having to draw a helper triangle. Okay, so I ended up with 527 over 625. And I'm going to try the same thing for the last one. So this says the cosine of 2 theta, and they give me cosine, so I'll use this formula. This is 2 cosine squared theta minus 1. So 2 times 15 over 17 squared minus 1. Now, remember, order of operations says you have to do the exponents first. So that's 225 over 289. Those are both perfect squares. 2 times 225 is 450. And I'm just going to say minus 289 minus 289. And 450 minus 289 is 161 over 289. So you can see these are a lot faster. Okay. Way easier than the tangent problems. But, again, it's just a matter of, do you understand that there is a formula that you can use and that you should use? And yes, these are the formulas for the double angles for cosine. Okay? So, go ahead and try your delta math and maybe smash that like and subscribe button.